Hi everybody, this is Granny. We're going to be solving radical equations and inequalities today. So first of all, a radical equation is an equation that has a radical sign in it. And what you'll notice over here on the right side of my notes is the steps for how to solve a radical equation. So let's go ahead and work through this first example together. The first thing we have to do is we have to isolate the radical. So we will subtract 5 from each side of this equation, giving us x minus 5 equals the square root of x plus 7. Now that we have the radical isolated, we know that the inverse of taking the square root is to square something. So what we have to do is square the left and right side of the equation. What you might want to remember is we're going to actually have to FOIL this, so you may want to write that twice so that you don't forget. In FOILing this, we get x squared minus 5x minus another 5x plus 25 equals, and on the right side, the squaring and the square root cancel each other out. And we just wind up with x plus 7. Because we have a quadratic, we're going to have to solve this, as we always do, by setting it equal to 0. So you can combine those minus 5x's if you want, or if you want to wait, you could do it now. Pretty simple combination. We get x squared minus 11x plus 18 equals 0. And now we need two numbers. We're going to have to factor this. We need two numbers that multiply to equal 18 that combine to equal negative 11. So, of course, we should get x minus 2 times x minus 9 equals 0. And that gives us two solutions of 9 and 2. And here's the deal. Just because we did all of our math correct doesn't mean that those answers are actually both going to work. So we actually have to check our answers when we have problems with radicals, because sometimes we get what we call an extraneous solution. So we're going to take our original equation and we're going to substitute 2 in to see if we get a true statement. So we'll get 2 equals the square root of 2 plus 7, and then plus 5 on the outside of that. Square root of 9 is 3. 3 plus 5 is 8. So we get the statement 2 equals 8, which of course is not true. What that tells us is, even though we did all of the math correctly, 2 is not a solution to our radical equation. Now we have to check our other solution in the same manner. So we think about our original equation, and we drop a 9 in everywhere we see an x. So we get 9 equals the square root of, we have 9 plus 7 under the radical, and then we have plus 5 outside of the radical. In here we get 16. The square root of 16 is 4. So we get 9 equals 4 plus 5, and that is true, 9 does equal 9. So that tells us that the only solution to this equation is 9. Okay, so you're always going to have to test your solutions when you have a radical equation. Sometimes one of them just doesn't work. Sometimes they both don't work, and we wind up with no solution. And sometimes they'll both work. Okay, moving on. Very similar. Now what we're going to do is we're going to solve a cubic equation. We're taking the cubed root here. So kind of the same steps. We have to isolate our cubed root. So we're going to subtract 8 from each side. And we know that the inverse of cubing, or taking the cubed root, is to cube something. They undo each other. So on the right side of the equation, we are left with just a simple x plus 2. On the left side of the equation, we have negative 4 times negative 4 times negative 4, which gives us negative 64. This is not a quadratic, it's just a linear equation. So we just subtract 2 from each side to solve. And what we get is negative 66 equals x. Right? Just like before, we have to check our solution. So we're going to take our original equation, and again, everywhere we see an x, we're going to drop in a negative 66. Make sure that plus 8 is outside of the radical. So negative 66 plus 2 is negative 64. The cubed root of negative 64 is negative 4. Okay? And when we clean this all up, we get that 4 equals 4. So that actually does work. And negative 66 is our only solution to this cubed root equation. Okay, so example 3 gets a little bit more challenging because what you'll notice is we actually have radicals on both sides of the equation. So what we're going to do is we're going to get radicals on opposite sides of the equation. Well, this one's already done for you. Sometimes you'll have two radicals on the same side and you'll have to move one over. Kind of the same routine though. We go ahead and we square each side. Now what I would do on this right side is I would rewrite it because I want to make sure that I FOIL it correctly. And it's going to help me to actually see it written out like that. The left side is easy. Those are going to cancel each other out and we just get x plus 10. On the right side, we're going to have to FOIL. So we get 25 minus 5 times the square root of 3 minus x. Actually get the same thing in here, so not minus another 5 times the square root of 3 minus x. And then be careful here because we have a negative times a negative, so we get a positive. And I like to put this inside parentheses. This one wasn't probably necessary, but sometimes when you have negatives or if you have a trinomial under here, it's going to be really important that you don't lose your sign. So let's go ahead and let's clean up what we can. So nothing really to do on the left side. But on the right side, we have 25, which can be combined with our 3. So we get 28 minus x. And then negative 5 times that radical minus 5 more gives us negative 10 times that radical. So at this point, we've done a lot of work, and you might think, well, why do we still have a radical in our equation? Well, the progress that we've made is we don't have two radicals in our equation. We only have one. So now it's like the problem from the previous page, where we want to move everything over to one side so we can isolate our radical. And we wind up with 2x minus 18 equals negative 10 times the square root of 3 minus x. Now having a coefficient in front of this term is okay, as long as we don't have plus or minus anything else. What I would do here though, is I notice that every term is divisible by 2, so I would go ahead and divide the entire equation by 2, just so I can deal with slightly smaller numbers. Okay, so that's a little bit easier. And now we go to exactly what we did on the other page, which is we square each side. On the left side, we get x squared minus 18x plus 81. And on the right side, be careful because we have to square the negative 5, which is our coefficient, so we get 25. And then the squaring and the square root cancel each other out, but 3 minus x is still inside parentheses. And that's important because you're going to have to distribute that 25. So left side is unchanged. Right side you have to distribute. And now again, we are dealing with a quadratic equation. It has x squared in it. So we have to set everything equal to 0, and hopefully we can factor. The equation we should get now is x squared plus 7x plus 6 equals 0. And we're looking for two numbers that multiply to equal 6 that add to equal 7. I don't think this is a tough one. You should easily get x plus 1 times x plus 6 equals 0. And we get the two solutions of -1 and -6. We're not done. Because just like we did earlier, we have to check our solution. So I'm going to ask you to pause this video. Go ahead and check your solutions, and let's see if we get the same answer. Okay, so hopefully in your check you realize that when you substitute -1 in, it actually works. When you substitute -6 in, that actually works. So this equation has two solutions, both -1 and -6. Okay, time for you to try a problem on your own. What I'd like for you to do is go ahead and try the next problem, do all the work out. You're going to pause this video, obviously, do the work out, and then come back and see if our solutions match each other. Good luck. I know you can do it. Okay, so here's the solution. Hopefully you were able to factor this 192. I thought that might give some people trouble. But if you put into your calculator in the y equals, if you put 192 over x and pull up the table, that may help you see the factors of 192. So if you're having trouble finding them, that would be a good help for you. In this case, x equals 8 worked, but x equals 24 did not work. So remember, we call that an extraneous solution. So take your time looking over your work, make sure you got this right, or at least if you didn't get it right, you find your mistake, and then you're ready to go ahead and do your homework. Have a great day.